doesn't accept more requests, you can actually automatically load the balance to the other VM, which is more identical to solve or to serve the same services. You can implement a public load balancer or internal load balancer. Public, as the name suggests, it's external. So when the external request comes in, it goes to the public load balancer and it points to the internal services. But you probably might have an application server connecting to multiple database server and just to internally load balancer. So when the one of the server is really heavy processing certain tasks, you can use another server using a load balancer to serve the request. Okay. So in the load balancer situation or the solutions, we have four different types. One is application gateway, other one is a front door. So here, um, let me just open this. So we have application gateway, front door, load balancer, which is typically given the name, and the traffic manager. They all for the different purposes. So you can read about the usage, but it uses a different protocols as well. Yeah. The traffic manager typically uses any protocols available, where application gateway and the front door uses HTTP, HTTPS, and HTTP2, where the load balancer uses TCP and UDP. Is that a private or regional? Yes. Application gateway, yes. Front door, no. And the load balancer, yes, but no traffic manager. But the traffic manager and front door is mainly for the global. Okay, so it sits on the public side. The environment-wise, they all sits on Azure. Application gateway, front door, and traffic manager can be on non-Azure cloud as well or on-premise as well. The security protocol for application gateway is WAF. Front door is WAF and NSG. Security is supported. Load balancer on the NSG. Okay. The scenario for load balancer is any request comes in here. The public load balancer distribute this request on the similar kind of port and the protocol. So it uses that. So that's how the it load balancer. Say request one comes, it goes to here. But request two comes, maybe it's this server is busy with the request one. It just puts a request two here. Request then three comes, it might put it on here or here. Then request four comes, it will just distribute it here. So this is based on the consumption and the the load it's getting to the resources, it just automatically distributes that based on the rules we have defined. The example of internal load balancer is these are the application layer. So say I got public here and public actually distributing request here. So this is my public load balancer. But here the internal load balancer has a multiple databases which again connects on same port and the protocol. So what it does, when the VM1 request, it requires a database connectivity. So say, for example, the request one comes here, request one goes here, the request one might end up here. So it depends on the how the rule has been defined and the resource availability is there. Okay. But the good thing is by setting this up, it's not exposing to the public network. So the front-end IP address and the virtual network are never directly exposed to an internet endpoint. Okay. So load balancer SKUs are the basic and standards, and there are some basic differences like 300 IP configuration here, 5,000 instances. We got TCP and HTTP support for basic, where a standard supports HTTPS. There's no availability zone, but here is a zone redundant zonal front ends for inbound and outbound traffic, and so on. Here, there is no SLA for the basic, but the standard has 4 nines, which is quite important. And as I said, the wherever you define the load balancer, you must define the rules. Rules are important. Without the rules, it's not going to identify what needs to be done. how it needs to be translated the request. Okay, so um, application gateway is another one which we need to learn. So you got application gateway, gateway routing, and setting up the application gateway components. So what is application gateway? So it manages a web app request. It's another type of resource in in Azure, and the application gateway uh, sends a request to the HTTP listener, goes to HTTP setting the rule, and the rule based actually allocation is happening. So route traffic to a pool of web servers based on the URL of a request. Now this request could be like, okay, if it is an image request, send it to this VM. If it is a video request, send it to this VM. Could be like that. Okay. So here is another example, path-based and multiple site routing. So say, for example, if it is a path-based, then you have a domain and domain / images goes to this pool. But when it goes to the video, it comes to this pool. In between, you have application gateway, which consists of WAF and the load balancer level 7. So that's how it's set up. In the multiple site routing, the request can come to application gateway and load balancer, but it uses the domain name to distribute to the pool. So that's a different domain, not a path, but different domain itself. Okay. So you got two types to remember, path and the multiple site. Okay. Network watcher, as the name suggests, it keeps an watch on the network and identifies any IP flow and to verify the diagnostics. It also puts a diagnostic on the next hop. So what's going to happen next? And on the next hop, what are the diagnostic needs to be captured to have an end-to-end view of what is happening, and also visualize the network topology. Yeah. So what other features we have in the network watcher is it's a regional service that provides the various network diagnostic and monitoring tools. It's important. So you got the there are multiple diagnostic tools are available, and each tool does its own different type of jobs. So I also does the monitoring and the different type of monitoring available, and there are sets of log needs to be collected to complete the monitoring and analysis. So IP flow verifies diagnosis connectivity issue. So you need to remember these tools, what it does. IP flow does diagnosis connectivity issue. Next hop determines if traffic is being correctly routed. Yeah. And VPN diagnostic troubleshoots gateways and connections, where the NSG flow logs tool maps IP traffic through a network security group. Okay, and then connection troubleshoot shows connectivity between source VM and the destination, and the topology is generates a visual diagram. It's just a more like a org chart hierarchical diagram it generates of all your resources. Okay, so these are the different screens of how the troubleshooting and the tools can be used. Going to quickly skip through on these ones. I would strongly recommend you read much more in detail about the Learn document. This is a topology example diagram. This is how it creates with the multiple resources. So you have a view of what it looks like in terms of the entirety of the landscape. So this architectural landscape can be presented as and when needed to have the full visibility. Okay, so this provides a visual representation of your networking elements and what views all the resources like virtual network, resources to resource association, relationship between resources, and so on. Okay, so here we go into we need to go into the lab environment. So let's go into the lab. Let's start with the demo. So in this demo, we're going to look into other aspect of what network watcher and virtual networking. So to do this demo, we have to execute certain commands. So what I have done, I've prepared some commands, and I've also got the portal ready, logged in. And we also have some ARM templates ready. So let's get started. So to give these commands, I will execute Cloud Shell. Once a Cloud Shell is connected, the first command we're going to give is to create a resource group. And to do that, let's set some variables. In this variable, we are targeting location East US, and we're giving a resource group name, which is AZ10406RG1. The next command I will give is to create a new resource group. And we don't need additional parameters like tag or value, like another forcing, because we haven't got any other resource group is created. So this is how we got the success of the resource group created. Let's go and check whether the resource group has created successfully. We're just going to wait for a couple of minutes. Yeah, here we go. So we got the resource group now created. So whenever we execute PowerShell scripts, it typically runs in the asynchronous mode in the background. And therefore, it might take some little bit of time before it gets executed. So next step we're going to do is we're going to use this parameter file, and we also going to use a template file. And those files will have it has all the definition of the resources we want to create. Those resources includes not only the virtual machine, but all the supporting components as well. So I'm just going to open those files and just to give you a quick overview. Excuse me. So here we go. This is our ARM template, and this one includes VM, what size we're going to create, and other parameters, which is supporting parameters. So here you can see the extensions, resource type, indexing, any properties, and all this stuff, which you can actually create a resource ARM template yourself, or you can actually click through in our previous demo. What you have seen is click through, create a resource, export as an ARM template, and you can reuse it. While reusing it, what element you need to change is the parameter. So in parameter, you can send all the custom values. So here, what I'm doing is I'm just sending a custom value for the VM size, which I'm targeting a particular type of size, which is standard D2SV3. And I'm also passing the username. Make sure you do not pass password in this parameter file. It's not that secure enough. Okay. So the next command we're going to execute is let's deploy using this template. Here, it's going to ask me for the password because the parameter is missing password, and I would prefer to keep it like this, and I recommend as well. Excuse me. So I've supplied a secure password and enter. This is going to take a little bit of time, so let's wait. It should not take more than 5 minutes. That's a kind of benchmark I have seen, but sometimes it's better to have that wait. Okay. While this is going on, I'm going to minimize Cloud Shell and let's monitor what happens in resource group one. So currently we don't have any resources. And as soon as I refresh, you will see the resources getting created. Okay. So it will do some refresh. So like in a couple of time, it will just set some of those information. So here, what we have created is within this resource group, we have created about 4 virtual machines, all required VNets, all required disk. We also have NSG, network security groups, and we have got NIC. So each virtual machine, we have one network interfaces here. Okay. So the next thing we're going to do, again, go back to Cloud Shell. While there are final piece of execution is going on, you will see the completion message here. At that time, you will we get the confirmation that everything is done and we're ready to execute next script. So in the next script, while this execution is going on, let's understand next script. So within this, what we're doing is we're deploying a network, network watcher extension. And this is where we're going to understand how the network watcher agent works on the VM. So here we are looping through each and every VM, going into that and implementing or deploying network watcher agent. Once it's deployed, network watcher agent will collect all necessary telemetry and pass it back to monitors and logs. Okay, so let's go back and check what is the status. The script execution is still happening, and probably it's setting up all the other settings. Let's give another refresh and see what is happening here. Okay, it's still in progress. Okay, here we go. So we have got the success from the previous script execution. So what it does is just it goes through the loop of the template and it created all the required resources. So what it did, it used the VM size, which we supplied in a parameter file. It used the VM name and suffix by 0, 1, 2, 3, 4. So because we executed about 4 VMs. So let's see, if all of the VMs are created. So if I just go and refresh this again, so we got 1, 2, 3, and 4. So 4 VMs are created with the NIC. We got 4 NSG, 3 NSG, and VMs, and the disk. We got 3 VNets. So this is a kind of enough for this exercise. So we're going to continue on this one. And let's execute this last script before we continue on our next part of the exercise. So in this script, you can assume that it's setting up the resource group name, location. It's getting it from the RG. So the resource group has a location. It's using the same location. It's got the VM names, which is under the VM name bit what we have set up. So it's actually looking for all the VMs within that location, like RG. And so here it's RG past resource group, and then doing the for loop, going through each and every VM and installing this network watcher agent. So let's wait. It should take about 5 minutes when it's installing network VM watcher. In the next step, what we will do is we will go through the virtual network and then look into the property and grab all this like resource IDs. So we can see like, what are those resource IDs? And then as a part of the next part of the exercise, we will allow some of the traffic. So we'll configure once the setup is complete. So if you are like screen grabbing or copying this script, just be mindful this script is designed for Windows agent, so it's not for the Linux. So you need to customize this script for the Linux version. Let's minimize this and let's see what is happening in our resource group level. So these are the VM configuration where you can access this VM using private IP because of the public IP is not assigned and we didn't actually configure for it. You can also use connect RDP. There will be IP requirement because it's a public IP. You need to use to connect to it. If you can't use the public IP and you don't want to use a public IP, what you can do, you can always use Bastion. This will come in our future demos. Okay, let's see what is the status of Network Watcher. Okay, it's still in progress. Should finish shortly. Okay, while this is going on, we can start doing a couple of other elements. So for the next step, I'm going to look for virtual networks. So when I look into the virtual networks, I got three VNets are created, 0, 1, 2, and 3. And within each of the virtual network, what you can do, you can go into virtual network, select the property, and within the property, you can actually look at resource ID. Second. think the blade has got stuck here. Okay, so we can go to properties and look at the resource ID. I would recommend you to copy this for this exercise, and I'm going to keep it into another location here. And this is a resource ID for VNet2, which we can actually see in the name itself here. And we're going to do the same thing for VNet2 as well. So let's try and copy from VNet2, sorry, VNet3. Okay. So we have copied VNet2 and 3. The reason I haven't copied VNet1 because we're going to go into VNet1 and then start peering. Okay, so let's go into resources here, Cloud Shell, and see the status. Okay, it probably has completed, but we're just waiting for the response. Okay, let's keep it minimized. What we can do, we can start on the VNet1, the next exercise, just to save some time. So within VNet1, we're going to go into settings and underneath the peering. Yeah. So within the peering, we're going to do add. And here we're going to supply certain details, like example, link name, just to identify what I'm doing. So AZ104, let's give, this is 6 labs. So VNet 01, 2. The peering is happening from 1 to 2. So I'm just going to give that name. So it makes it easy for me to understand. But please follow your organizations or customers' naming strategy. So that's how you don't have any other surprises. Okay. Here we're going to leave the remote virtual network allowed. We also going to have um, the virtual network traffic. We're going to block this here. So let's see. We're not doing any kind of forwarding traffic. So that's why we're blocking it. And we also going to leave the routing is to none because we're not adding that anything. And the pairing link value. So here, the link name, we're going to give the resource name. So it's just got stuck. Okay. So let's give a name here, which is AZ104. Now here, I'm going to put down reverse naming just for the identification. So what we did at the start of the setting up, we did the VNet 1 to 2. Now, what we're going to do as a reverse name here, the resource ID link. Sorry, this is a wrong tab. Wrong one here. So I'm going to say simply 2201. So that's how I can see the reverse mapping there. Now we know the resource ID, and that's what we recorded. So for 2, we know this is a resource ID. So let me copy this resource ID. Let's go and paste here. And we're going to allow a remote virtual network. We're also going to allow the traffic forwarded from remote virtual network for this one. And we're going to leave the route to none. Okay, let's hit add. Here, we need to wait for the operation to complete, and it looks like it has completed, but it's still updating. So let's wait for the update to complete. It is now connected, so brilliant. That's actually got that completed. Now, the next step, we're going to do the same thing, but for peering for virtual network 3. Okay, so we're going to add again and peering link. This is going to be 0, 1, 2. This one is 3. Okay. We again going to have, this is like an allow block routing from here, set the root server to none. And the remote virtual network, we're going to give the name, the reverse name. If you remember the previous one, we did the reverse naming just to identify. So I can simply just copy this. Okay. In this one, we already know the resource ID as well. So I'm going to take, I know my resource ID, and this time we're going to copy third one because now we're connecting VNet 1 to VNet 3. That's the peering we're setting it up. Okay, and we will leave the setup as is. So allow virtual network, allow remote virtual network, forward it, and we're not going to have any route server, so none. Let's add. Has been added and it's just updating now. Okay, it's all connected now. So now in this, like another through the portal, we're going to now set up a network watcher. So we install the agent, we did the peering. So now the connectivity has been established. And we now going to do network watcher. So within the network watcher, we going to see like in a connection troubleshooting. So here we can see the network watcher East US got set up here. So we can actually go and look at all these details. But before we do, we're going to look at the connection troubleshoot. It's down here. So in the network diagnostic tool, so if you remember in the previous slides, we've been through each and every tool, including IP flow, NSG diagnostic, and so on. But this one, we just going to demonstrate about the connection troubleshoot because we just established connection. So let's see how the troubleshooting works. So in this one, we have the subscription, which is a correctly set up, resource group correctly set up, resource type, we are connecting as a virtual machine. So we will leave to virtual machine. We're going to select the virtual machine, which is a specific. So we will leave to virtual machine 0 because from there to be connecting others. So we'll leave it to 0 for now. And destination type is going to be, we're going to specify manually with the IP address. So rather, you can also do this way, connecting to the VM and set up VM1. But here, we're just going to specify the IP because you can also experience this one. So currently, not sure if you have noticed, when I opened a virtual machine, you probably have seen the virtual machine private IP. So this is what we're going to copy paste here. So it didn't copy very well. So let me type it 10.62.0.4. So this is the IP we like troubleshooting the connection against. And also we got the TCP as a protocol destination port. Here we're going to troubleshoot against 3389. And if you remember, 3389 is a RDP port. Okay. And we're going to leave all four of them all of them selected. So connectivity, NSC diagnostic, next hope, and port scanner. So let's run diagnostics test. So once it succeeds, we will be able to see like what is a troubleshooting look like. Okay. And after this, we will do the same troubleshooting with another destination as well, which is a different IP. So what we have as outcome, we got connectivity test is succeeded with all the latency detail. Any suggestion, if there are any improvement or anything needed, the suggestion will be given here. We then have NSG outbound and next hope, all this success. And you can see this VM1 connected to NIC2. So network interface 2, which is associated with VM2. So that's where it's connected and looked at the full detail on it. And also we see the topology here. So this is another tool provided by Azure, which is, let me just enlarge it if you can. Sorry, it's a bit, okay, now it's coming up. So this is how the topology look like. So it's a VM0 connected to NIC2, and these are the IP addresses. This is how the connection success has happened. Now the same thing we're going to run for another IP. So I'm going to leave all the settings as is. But here I'm going to change IP address to 10.63 instead of 62. So let's rerun this test again. Okay, it should be back again soon. Great. So here in this one, the outcome is, let's see, the success. So that's good. That's a good sign. And also we have the connectivity, which is from VM0 to network interface 3 now, network 3. So that's where this is connecting. So you can see this we can easily troubleshoot between two locations which we have set up as a peering. So that's something we can do. Also, we can give it a try on different virtual machines. So I can set literally virtual machine, say 2, and ask virtual machine to let's try and check the connectivity between the same IP with the virtual machine 2 and see what happens. Yeah. And I'm expecting this is a failure because we're trying to connect to the same. So let's see. Okay, it should come back soon. When it goes to the failure, it's my personal observation, but it just takes a little bit longer than the success one, because for the failure, it probably does multiple retry, but don't count me on it. This is like my observation. Yeah, it should be back soon. This is exactly the correct expectation I'm trying to set here. So we should get the failure here. And So I can demonstrate the failure here. Okay. Uh, so next part of the activity, what we'll do, we will try and get the IP forwarding enabled, which we did left it disabled in the previous step. And then we will try and include, like, try and install some of the management tools using a script. So here you can literally see it's failed, and it probably did probes 30, sent, failed 30, all of them. The fail test following NSG as well. So this NH, it has failed. Um, and it also shows, what is a failure type here. And what we try to do is connecting from VM to the destination, which we don't have any peering to. Yeah. Okay. So this is a kind of more like a troubleshooting on the network watcher. So within this, you can use any of those tools to troubleshoot your existing establishment if something goes wrong. Okay. Now, what we're going to do, we're going to search for a virtual machine as a type of next task. And this is about we configuring routing in the hub and spoke topology. So let's do that. I'm now going to save this. So I got virtual machine. I'm going to select virtual machine 0, then go to settings and networking. So within this networking, and I'm going to go into network label, which is NIC0. Yeah, okay. And next to that, we have, let me just click on that. And within this one, I'm going to go into the IP configuration. So what I did, we have virtual machine, which has NIC connected to it, which is network interface 0. And within the network interface, we have IP configuration, and you can see IP config 1. So here, what we're going to do within this one, IP configuration, and we're going to set enable IP forwarding. Okay. Now let's apply this. Okay, so it's got the network interface got updated. Let's go and refresh this. It looks good. Okay, we're going to go into overview. And here we can see that, once it's loaded. Okay, so here you can see this, where it's attached to, what is a subnet, what is the IP address, and the type regular, and all the details, what the basic details, what you need. It's all available here. Okay. Now, what we're going to do, we're going to run a PowerShell script. So just to install some of the one of the setting, which is, let me just copy this command. And for that, I'm just going to go back into VM. So we have executed command using PowerShell script, but here we're going to try something different because I want to install something on the VM directly. And there's a way to do it is under the operations, we can go into run command. So when I run this command, it actually gets executed directly on the machine itself. So I can run a PowerShell script here. So when I click on PowerShell script, it's going to ask me which command I want to run. So if I paste the command, so let me type in install hyphen Windows feature remote access. Okay, just going to quickly check all the spelling because sometimes when you type, it just adds some additional characters. So what we have done here, install Windows feature. So you can also open up the VM and go and install Windows feature manually. But if you don't want to log into VM, save some time. And if you're running on a multiple VMs like this, you can typically execute scripts like that. So I'm just doing Windows, installing Windows feature. Remote access is the feature I'm installing, and which includes the management tool as well. So let's run this. While this is running, I'm just going to copy some more script here. So let's open up a new tab. So in this next exercise, what we are trying to do is we're installing some more features like routing, RSET. We also adding the remote access and VPN type for routing only, and we going to get the network adapter and the SAT IP interface to forwarding. Yeah. So these are the commands we're going to execute. So let's see what happened in Azure. Yeah. Great. So we got the commands is now succeed. So it's absolutely great. It's all done. And here I'm going to copy these commands now, which we want to execute. Okay. There are, when you're doing a copy paste, make sure you just retype any characters, any special characters if you have a doubt, particularly with a hyphen. If you have a long hyphen, make sure you do that because those character copy pasting is just sometime gets a Unicode characters and that could create a problem. Okay. So we're going to wait for this confirmation of this execution command. And as I say, what it is doing is in the first command, it's doing installation of the feature called routing, and it also includes sub features. The next one it's doing is the feature called RSET remote access PowerShell. The third one, it says remote access is a VPN type and VPN type is a routing only. And then the fourth one, it does the getting the net adapter details, then setting a net IP interface forwarding enable. So that this is what it's doing. Okay. So script execution is still in progress. And while this is going on, let's see if we can perform any other task. The next task is actually dependent on that. So let's wait. So sometimes these scripts take time, so just give some time on it. Or you can run batch of the script and leave it to it and monitor the response later on in your real scenarios. So here we can see that it's getting succeeded. So okay, and it's got all the necessary stuff installed. So now what we can do, the next step, we going to perform a couple of route table. Okay, let me just close this. Everything looks good. We're going to go into route tables. We then going to add some of the routing. So let's wait for the response. Subscription is that. We're going to select resource group to RG1 I'll leave the region to same STUS, and let's give a name. Okay, the settings I have done, like which we trying to create a network route from 2 to 3. So I've just given a name like routing from 2 to 3, and we're going to leave propagate gateway routes to no. Okay, so I don't want to apply any tags, but in the best practice, please make sure you apply the tags as per your organization's policy. Okay, it should be just waiting for the response here. Okay, brilliant. So we got the response. Now we're going to go to that resource. Yeah, so we have created successfully. In this one, within the settings, we're going to go to routes. And within this, we're going to add routing here. Okay, so let's give a route name. Okay, so what we are adding is routing table is from VNet2 to VNet3. And the IP address, we're going to specify. Okay, so it came back, and it's a CIDR range, so 10.60.0.4. And sorry, we're going to apply from the 2. So this is going to be 63. And 0.0/20 CIDR, that's address range is the one we have set up on VNet3 subnetting. Next hop is going to be the virtual appliance. And the next hop address is going to be 10.60.0.4. So the IP address is I'm giving here because based on the template what I built, I got those IP set up. So either you can look at the template or you can go back to those resources, make sure you note down all these IP addresses and then put it down. Okay, so let's add the route. Okay, so now we added the route. We're going to go and add a subnet as well. So let's associate a subnet. So within this one, in associate, we're going to have VNet2 because this is what we are targeting, and leave the subnet name to 0. It's okay. Okay. So now what we have done, we added a route. We also then added a subnetting. We're going to perform the similar exercise for another route. So if I just go back to the overview. So we created a routing from 2 to 3. Let's go into route table again. And now this time we're going to create a route from 3 to 2. So we're going to add another one. Yeah. And this one we will give the name to and we'll leave this to no, preview and create. Okay, we're just going to wait. Okay, we got this spinned up quickly. Now, we again, just to complete this exercise, then we so we can actually complete the network watcher exercise using this route table. I'm going to do the same thing again here, adding a route, and this one we're going to call is 0406, and this time the route will be from VNet 3 to VNet 2. Okay. The destination type is going to be IP address, and this time I'm going to give the IP address of 2. So 10.62. And next hop is going to be again my appliance, and that's the appliance IP address is the same as what we applied before, 10.60.0.4. So I've got it right. Yeah, okay. And we're also going to add the subnet as well. Okay, so that's done. So let's add a subnet association again. And this one, we're going to have subnet of 3. So remember, we're going to create 3 to 2. So subnet will be 3. We created where the previous one, which is 2 to 3, where subnet was 2 for the VNet 2. So this is how it matches up. Okay, so we now created successfully all this routing requirement, what we need. So now what we're going to do is we're going to go back to the network watcher again. Click on the one we have already got. Or probably we can just simply use the connection troubleshooting here. So in this one, what we're going to do is we're going to leave the virtual machine as here. Instead of virtual machine 0, we're going to use virtual machine 2. And we're going to specify manually. And this one, if you remember, the IP address is 63.0.4 for the VNet 3. And this is how we're doing the troubleshooting from VM2 to VNet 3. So we given 63.0.4, and the destination port, again, we're going to select the RDP port. So it just makes it easy. TCP, and we're going to leave to 4 selected. Yes. Okay, let's run a test. The last test we ran, if you remember, it was failing on the same configuration. So now we're going to try and see, if this passes. Okay, so here we go. So we got all the success tests done between that after setting up a route, and it also gives all the information. If you have something like this, the info, you can see the what is the error, IP forwarding not enabled for this particular IP. So that's why you get this warning here. So, and it gives you the suggestion what needs to be done. And here you can see on the topology, this is where the forwarding is not enabled, and that's why you're getting the error. So what you will do is simply go back there and just enable the forwarding, and that will complete the testing. Okay, so here we go. We kind of completed all the demo session for the network watcher and how the connectivity happens between multiple virtual networks, how we can utilize route table to establish routing. And this is where we got. So thank you for joining today.